So, talk now is on Max Tegemark on Fast the Light, and we're going to go to wiki here, and then we're going to go to his book and so forth, and he's got a song at this address here. So I'm going to go through all this. Right, so going to where he is. This is Max Tegemark on Wikipedia. He's a professor at the Massachusetts Institute of Technology, MIT, and is a scientific director of the Foundational Questions Institute. So he describes his field as cosmology and physics. So cosmology is the sort of stuff they built from Einstein's relativity. So that's the person. Alright, go to so we go to his book now. He's got this book out, it's also described on Wikipedia. It's called Our Mathematical Universe. Our Mathematical Universe, My Quest for the Ultimate Nature Reality. It says it's by him. New York Times says an informative survey of exciting recent developments in astrophysics and quantum theory. And he's got his mathematical universe hypothesis and so forth. So I've got the book. There's quite a lot to go through, but I'm only pointing out a few things. I'm going on to the fast and light bit, and since the book is, I don't know if it comes out very clear on this video, so I've photocopied the relevant pages. So here we go. Let's have a look at the page. Hopefully this should be clear enough. So he's got a diagram here. He's calling it he says distant galaxies recede from one another like chocolate chips in a let's see, I'll go closer, an arising muffin. From the vantage point of any one of them, all other things are moving straight away with a speed proportional to their distance. But if we think of space as stretching as the muffin dough does, then the galaxies aren't moving relative to space, and space simply has all its distances stretched uniformly, as if we relabeled the tick marks on our rulers from millimeters to centimeters. So he's comparing this to that. That's galaxies are supposed to be receding from each other, and in this one it's supposed to be chocolate chips receding from each other. So this stuff at the muffin is rising, and he wants you to think of that muffin, the dough, as being like space. So I think it's a pretty poor analogy between the two. So that's the substance, and this one is supposed to be empty space. So this substance is expanding, and this space is expanding, and what we got here is a substance, and it's expanding into space. But he wants you to think of just that space itself as expanding. So it's not quite right, really. If it was really like this, if galaxies were really like this, then the galaxies would be in a substance and it would be expanding into space. So that's sort of one of the changes sort of Einstein's made. You've got to stop with the absolute space and absolute time of Newton, and think of space itself as being like a substance and expanding. So it's very weird. Why do you want to make a change like that? But that sort of thing that Einstein's done, he's changed it. So, but then they carried on with that, and of course in my videos I'm pointing out, why do you make the change? It's sort of like, doesn't make sense. Galaxies expanding, well, you could think of it as in a substance and expanding out in that substance, and then they waffle on in these other speculation things in theoretical physics about things like dark matter and dark energy. It sounds like it's really galaxies are moving in the sort of substance. So, but anyway, they start off with this idea that space is empty and the galaxies are moving in expanding space. So I think this sort of thing fails a bit, really. But anyway, we go on to his little talk about it. He goes on to lots of other things. He's got to explain all this setup. And we get on to the bit where he has about faster than light. So if we get to the next further on, we get on to the idea making sense of an expanding universe. After Hubble's measurements were announced, even Einstein was convinced, and now our universe was expanding even officially. But what does it mean that our universe is expanding? Well, first of all, I'll point out that even officially, what does that mean really? It's sounding like, well, you only accept if Einstein agrees with it, and so no, that's not very good at all, really. So Hubble's given his measurements, and Einstein's got to agree as to what that means, and so it means it's an interpretation of those results from Einstein's relativity. So why are they doing that? Why can't you just carry on with Newtonian physics? So if we go back to this thing, it's this flip from a substance, it could be expanding in the substance, or is it expanding in empty space? So why are the changes? What's going on? But anyway, if we carry on, we are now ready to tackle 4 more of the questions from the beginning of chapter 2. So here we go, we're going to get into the idea of faster than light. First of all, are galaxies really moving away from us, or is space just expanding? Conveniently, Einstein's theory of gravity, general relativity, says that these are 2 equivalent viewpoints that are equally valid, as illustrated in figure 3.2. So you're free to think about it in whichever way you find more intuitive. What? So go back to this figure. This is the figure 3.2, and so you're looking at that. You could think of galaxies being in a substance, and the substance is expanding, and space isn't itself expanding, and this one, it's space itself expanding. So that would seem to be more the Newtonian way of doing it, and that's sort of like the way that Einstein's changed it. Why the change? If that's the existing way, why not stay with it? So, but he says you're free to choose what you want to do. So, you don't have to go to Newtonian physics. You don't have to leave Newtonian physics. You don't have to go to Einstein's general relativity. You can just stay with Newtonian physics. That one. You're free to choose. So am I interpreting what he's saying correctly? I mean, this is a big problem. It's a big problem. is he saying what he says he's saying. If we go now to this one of my talks, it remains unanswered as to what Einstein's relativity is, and I'm referring to a paper in the mainstream, and they can't really agree what Einstein's relativity is. So this person, Max Tegemark, is it just his opinion about these things? He's saying here you're free to choose between whatever way you want to do it, which would mean you could just stay with Newtonian physics if you wanted to. And as I point out, because they don't really understand what Einstein's relativity is, all these different people are saying different things. So presumably from his point of view, if we're getting it correctly, you can stay with Newtonian physics if you want to. He's saying you can free to choose. He might just, if you push him on that subject, he might just bluff you like other people like him do, because he's stating something here which may not be what everybody else, as the Einstein believers, want to believe. So there we go. We can get back to it now. You are free to think about. You are free to think about it in whichever way you find more intuitive. He's got a star there. We go to that in a minute. From the first viewpoint, space isn't changing, but the galaxies are moving through space like the chocolate chips in a muffin. That's rising because of the baking powder you put in the batter. Yeah, Newtonian. That would be a sort of like Newtonian. All galaxies, chocolate chips, move farther apart from all others, and more widely separated pairs get separated faster. In particular, if you are standing on a specific chocolate chip galaxy, you see that the motion of all the others relative to you obeys Hubble's law. They are all receding straight away from you, and one twice as far recedes at twice the speed. So if we're going on to Newtonian physics, well, we can just carry on with Newtonian physics. Well, that's alright then. The farther away these galaxies are, the faster they're moving. And we can think about that in the context of Newtonian physics. Remarkably, things will look the same whichever chocolate chip or galaxy you're observing from. So if the distribution of galaxies has no end, then the expansion has no centre. It looks the same from everywhere. From the second viewpoint, space, like the muffin dough, it expands. So just as the chocolate chips aren't moving relative to the dough, the galaxies aren't moving through space. So this is the second way. This would be sort of like Einstein. You're thinking that the space is expanding. Right, so, but you can still carry on thinking about it in the Newtonian way. Instead, we can think of the galaxies as being at rest in space. And figure 3.2, right, that was the diagram I referred you to. While all the distances between them get redefined, it's as if the thick tick marks on the imaginary rulers connecting the galaxies get relabelled, so that their spacing corresponds not to a millimetre but to a centimetre. Now all intergalactic distances are 10 times larger than they used to be. So what's happening is your ruler is expanding. Distances are expanding. Well, I don't quite understand whether that is supposed to be that your ruler is expanding or not, because you'd have to keep something not expanding to compare it to space expanding. So you've got a bit of confusion here really. Is your measuring instrument expanding with the universe or not? I think this is what one of the big problems with Einstein's relativity. This second viewpoint, which is Einstein's relativity, is all rather messed up. People in that will start to say different things, where if space is expanding, you need a ruler which doesn't expand with the space to actually measure that. So if we carry on, this answers another one of our questions Don't galaxies receding faster than the speed of light violate relativity theory? Question mark. Relativity theory, he means Einstein's relativity, because if I pointed out in some of my videos, relativity was really around before Einstein. But if we're going back up here, the first viewpoint, he's saying you can still carry on with the first viewpoint, which is Newtonian physics. So why go to all this mess with Einstein? But anyway, carrying on with the mess that Einstein makes, the second viewpoint. One of our questions: don't galaxies receding faster than the speed of light violate relativity theory, Einstein's relativity? Hubble's law, V equals hd. I hope you know what that is. It's velocity, Hubble's parameter, and distance, implies that galaxies will move away from us faster than the speed of light c if their distances from us greater than c divided by h equals 14 billion light years, and if we have no reason to doubt that such galaxies exist. So doesn't this violate Einstein's claim that nothing can go faster than light? So that's the big question. So going by this equation, you've got, looking at galaxies, you say, well, some speeds are faster than the speed of light c, and would that violate Einstein's special relativity and so forth? And so get into the nitty gritty, the question mark. Okay, the answer is yes and no. Right? So basically it's a big fudge now, it's a big fudge. Fudge, we're putting a lot of fudge onto it now. You can't give a straight answer. And part of the problem is, as I pointed out here, they can't agree. They can't agree what Einstein's relativity is. So his Max Tegemark, whether he admits it or not, it's really giving his interpretation of Einstein's relativity. He's trying to make sense of it. And his answer to that straightforward question is yes and no. So that's his way of trying to fudge it to get around the problem. It violates Einstein's special relativity from 1905, but not its general relativity from 1915, and the latter is Einstein's final word on the subject, so we're okay. So, sorry for the coughing there, needed a glass of water. So if we get back to it, this is one of the big fudge things they do. You've got Einstein's special relativity and you've got the general relativity. So you're saying one thing one moment in special relativity, and the next minute you are changing things and saying something else in general relativity. So you are making more fudge. This is where you get the fudge from. The answer is yes and no. It's all fudge. Fudge. Einstein effectively is changing his mind, and you're saying it's Einstein's final word on the subject. So, well, you could look at it that way, or actually Einstein was looking for a unified field theory. So that's another way of looking at it. So it's really special relativity, general relativity, and you don't have Einstein's final theory, which is unified field theory, because Einstein is so not being able to get that. So what you've got is incomplete theories. Anyway, let's look at the footnote. He says here, mathematically, the different viewpoints, which is essentially Newton viewpoint versus Einstein, correspond to different choices of space coordinates, and Einstein's theory allows you to pick whichever coordinate system you want for space and time. So the one we want really is to go back to Newton. Einstein's given you a choice of where you want to do it, but well, let's carry on with Newton. That's a good choice, isn't it? Anyway, carrying on, general relativity liberalises the speed limit. So from special relativity, you've got this idea that the speed of light is the speed limit, whereas special relativity says that no two objects can move faster than light relative to one another under any circumstances. That's special relativity, the speed limit. Right. General relativity merely insists that they can't move faster than light relative to one another when they're in the same place. What? Huh? Same place? that is completely crazy. What's he saying here? But basically, you see, you have special relativity saying one thing, and now we've got general relativity, which is supposed to be saying something else. So you've got a speed limit for special relativity with the speed of light c and all this other nonsense from it, and associate it's supposed to change in general relativity, and it's the fudge. In contrast, the galaxy speeding away from us superliminally are all very far from us. If we think of space as expanding, then we can rephrase this by saying that nothing is allowed to move faster than light through space, but space itself is free to stretch however fast it wants to. So this is where we get in all the science fiction idea of Star Trek, space warps and so forth, where space can itself expand faster than the speed of light. So if we go back to now the diagram here, we have, this is essentially the Newtonian way of looking at it. Galaxies and sort of a substance. Space is not changing, they're in a sort of, galaxies are in a substance, and these galaxies, they can expand at any speed they want, faster than the speed of light or whatever. Then we go to this one, and this is the Einstein way, and you're thinking of space, and space can expand at any speed it likes. It can go faster than the speed of light. And according to Max, you can think of it that way, or we think it that way. So that's still carrying on with Newton physics. Why the change? So if we go to what's going on here, this is another one of my videos. If we go here, when we're dealing with special relativity, what they do is they form this triangle. They form that triangle, and they play around with that, and they say, all that gives us time dilation. And there you go, time dilation, special relativity. But the question is, why do they do that to that triangle? Looking at that triangle, you have a speed c along the hypotenuse, and you've got a speed along here of that. So you've got a speed of light along here as slower than the speed of light along here. So the speed of light, you can go faster than the speed of light. If you're thinking that is the speed of light, then you can go faster. You can go at a faster speed. So basically, within Newtonian physics, that is just Newtonian physics. That is Newtonian physics. If you think of that in the way of Newtonian physics, you can go faster than the speed of light. There is no need for this. There is no need for what Einstein did with that sort of mess. You've got that mess. You've got, well, we're not going to, when we mess it up like that, we're not going to have speeds faster than the speed of light when you do that mess. So then he does that mess in special relativity, and then next minute Max is going to tell us it all changes in general relativity. So after making that mess in special relativity, you then got to amend it. You've got to add more fudge onto it, which is essentially what Max is doing. If you can just go straight on, if you carry on with the contrast of two viewpoints here, you've got this one and this one. That viewpoint, which is Einstein, you've done messed up the maths with special relativity. You then have to add more fudge to that with general relativity and come up with the idea, well, special relativity doesn't allow you to go faster than the speed of light, but now in general relativity you can, and you're attributing that faster than the speed of light to space itself. Okay, so that's Einstein's way of doing it. But as what Max says, we can still carry on this way. We can still think of galaxies as expanding in a sort of substance, and space and time not changing. The Newtonian way of doing it, we can still do it that way. And then you've got faster than the speed of light within the context of Newtonian physics. It's just straightforward that way. And he says you can do it either way you like, but that way involves a lot more fudging, a lot more mistakes. See, where Einstein did it, he sort of acted autistic. He made a mistake, and rather than correct the mistake, you just kept adding more and more mistakes. So this method, you just add more and more mistakes. And that's why they all get confused when you go to the articles in the mainstream. But what's Einstein doing? We don't even know what his theory is. He didn't finish it. He was working from special relativity to general relativity, and so say going to unified field theory. It never got there. But I got there. I just said, well, what Einstein's doing is all a mistake. And really, you go back to an earlier person, which is Boscovich. If we can put him up. Boscovich. So, these are my books. They've got various books now on the internet, and I'm saying it's Boscovich theory, this one. The first unified field theory was Boscovich in the 18th century. So if you're not doing it the way Einstein's doing it, then you're not making these mistakes, and he's just building more and more mistakes on it. And you just go back to how physics was before Einstein, and you say, well, there was unified field theory before Einstein. Have I got the other one? Let's have a look. Oh, can't see it. I could put the other one. That one. This is another one by. This is a book I translated by my friend from Dragoslav. He's written about Boscovich, so I've done that. Dragoslav Stokovich. He's written a book. I've translated that. And what we're saying is, Boscovich provided the foundations of modern science. The book deals with the historical context of Boscovich's unified field theory, along with recent applications. And what we find that Einstein was really going from physics from this, and he just introduced lots of mistakes. As I say, he acted like a sort of autistic person. He makes a mistake, and then he just builds on it. He just keeps adding more and more mistakes. And of course, with Einstein being considered a super mega genius, he's got a lot of followers, and they all decide to do exactly the same thing. So if you go back to this picture, this Max Tegemark is saying, oh, you can do it from this way or this way. This way is Newtonian physics. And you've got a substance in it. You've got a substance. You've got space, and you've got substance in that space. So the galaxies are in a sort of substance. And this way, you're just trying to think of empty space, with empty space expanding. So in this way, you would have to add a lot more fudge. You'd have to add things like dark matter and dark energy and all that other stuff, which they're now coming up with to try to fix observations into this distorted Einstein way of doing things. So if we go back now, so Max Tegemark, here he is. He's a professor, and he teaches this Einstein's relativity, and the way he teaches it is to inspire his students by sometimes singing to them. So here we go. We could do his song now. So there's Max, and he's going to sing for us about how wonderful Einstein is.
Something else, it was right.
Going on to Einstein's ideas upon all this, and it's of course it's Einstein that's messing it all up, but sort of like they are singing how wonderful he is. There we go. Here we go. And of course, relativity before Einstein. There was relativity before Einstein, but the way they're singing it, they're saying it's kind of like this relativity coming from Einstein and how wonderful he is. But actually, what we find really is that Einstein's messing up relativity. So Lorentz transformation, the relevant maths, and of course Einstein is messing up the maths. And so we have Lorentz was dealing with the maths before Einstein, then Einstein comes along and decides to mess it up. So Einstein messes it up with Einstein's way of wanting to interpret that maths and so forth. And this is what's also crazy about the way Einstein does things. You've got sort of like, you can look at it as a smooth process in physics of working on Newtonian physics, then Einstein comes along and changes everything about how you're supposed to interpret it. So this is supposed to be two people that are making observations and they're moving relative to each other. Just the maths being messed up by Einstein. So we all believe in relativity. It should really be, you should teach, ideally you should teach a class to be critical of what they're being taught, but this sort of thing is, well, we want you to disbelieve it, we don't want you to be critical. That's what this sort of message is. This is how bad the education system becomes, because you should be teaching kids critical thinking, but I think it's now out of the teaching system. What you want to do is you want to teach children, our students and stuff, and you want them to believe what the professor is telling them. You don't want them to criticise it. You want them then to answer the questions in the way that has been presented to them. You don't want them to suddenly say, well, what's being taught to me, this is all a load of nonsense. You don't want critical thinking, and I've covered that in some of my videos, that the teaching system is now bad. And sort of like this is for the general public. Well, people sort of say, well, E equals mc squared, and it's sort of proven by the atom bomb, but you can actually look at E equals mc squared from different theories. It doesn't really prove one particular theory, i.e. Einstein's. You can look at it, say, from Newtonian physics. So the delusion in people, general public's mind, E equals mc squared, E equals mc squared from Einstein, and that is proved by the atom bomb. So it's a really hard image to overcome. So you've got Einstein being worshipped as a super celebrity, so Einstein's made all these mistakes, but suddenly you're getting it glossed over by the massive publicity campaign which is coming out. Einstein being shown everywhere as a super mega genius. Which was basically Einstein moving on from special relativity and now going to mess up gravity. It's just carrying on building on the mistakes. That's them shaking, not me. And sort of Stephen Crothers has gone into this issue of black holes, and it's really been messed up by Einstein. So when a really massive object collapses, what they call it from the perspective of Einstein's relativity is that eventually, if it's so massive, then it forms a black hole. But really, looking at it from Einstein's relativity, it really gets messed up. It becomes this issue again of they don't really know what Einstein's relativity is. It's just a big pile of mistakes. And so they look at it and they try to sort out the mistakes. So Stephen Hawking, another person they're promoting, is this super mega genius. They promoted Einstein and now they're promoting Stephen Hawking. So you've got this celebrity thing going on, super genius, and it's very difficult to criticise something when it's being presented in that sort of way. So he's saying here, galaxy expanding in space, and so as you go back here, he did point out that you can do it either way. You've got the Einstein way, and you've got the Newtonian way. So the choice is yours, which way you want to do it. So really, this is he's not pointing out properly in the song. You've got a choice of how you want to do things. So I'm actually criticising the song now. I'm saying the song is not really going into proper details. It's given this distorted picture of you must believe in Einstein and answer the questions in your exam in the way which conform to this belief. So that is really distorted, really, because the same rival theories are now known. Then if you go back to here, the rival theory is to do with Newtonian physics rather than Einstein, and so it's rather distorting things by saying that. There's far more to it than that. So I'm actually criticising this song again. It's not really going into sufficient detail. It's not pointing out that you don't have to do things Einstein's way. It's kind of still giving the false impression. Max. So that's the end of the song. So that's the indoctrination process for the students. And so really, if we go into the details, going by his book, he's given what he thinks Einstein's relativity means, and going from what his book says, it's sounding like, well, he's saying that you can do it by Newtonian physics. Whether he wants to really accept that's what he was saying, you sort of like, probably might try to fudge that. But reading the book, he's saying on that issue, oh, you can do it by Newtonian physics if you want to. And it's all just about coordinates. So, is that really what he's trying to say in the book? Or is that really what the other people who believe in Einstein think? It's sort of, well, it's the usual mess with Einstein. You've got the mess from Einstein and they've just built upon it. And if we go back to that, well, it all builds upon this mess. You've just hidden what is really light speeds, it change. Light doesn't stay at a constant speed, and rather than accept that, you decided to come up with things like time dilation. You've tried to mess up the mass and make it time dilation, and it just carries on from that. So they've just built on it. This is the book, Mathematical Universe. Does he really mean what he's saying in the book? Right. They seem to say, criticism book seems to reflect two prominent criticisms also made of Tegemark's Mathematical Universe hypothesis. So he's written his book, he's written down what he thinks, and people are criticising it. So this is the big problem. If I go back to that video, it remains unanswered as to what Einstein's relativity is. You get these people who believe in Einstein's relativity, and they're all going to come up with different things to believe in. And Einstein, well, you look at him for help, and you find he just keeps changing his mind. And then you say, well, maybe, what is the final theory? Well, some people say, well, the final theory is general relativity, but that's supposed to be incomplete theory. He was still trying to work out his completed theory, which was unified field theory, and which I picked it up. I say, yeah, it's Boscovich, him. Before Einstein, there was a unified field theory. Why bother with Einstein? Thank you.